Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
Ajay, welcome to Insider's Guide. How are you doing today? Tell us a little bit about your role at Lifecycle and why it's so important for battery recycling and the broader EV industry.
Thanks, Jeff and Chris, and great to be on. So let me start with a bit about Lifecycle really briefly, and then I'll talk a bit about the industry. So we're a lithium-ion battery recycling company. We take all types of rechargeable lithium-ion batteries. Think of the smallest you can, like a battery in your smartwatch, all up to the biggest you can, even heavy-duty trucks that are increasingly getting electrified, and everything in between. And we recover the critical materials within, so lithium, nickel, cobalt. I really think about these as the building blocks of new lithium batteries and also the energy transition. Zooming out, why is this important? Our transition to renewable energy is very reliant on storage. Lithium batteries are a large part of the equation there, especially for mobility applications. And lithium batteries are very intensive from a need for critical materials, be it lithium, could be nickel, could be cobalt. So really think about lithium battery recycling as the future urban mine for getting these materials, moving away from primary mining and moving towards recycling, resource recovery. Maybe one last stat to provide, by 2040, globally, we're looking at about 30 million tons of material that needs to be recycled from lithium batteries that are both dead and also from making of batteries. And that's worth about $110 billion in terms of the total addressable market. So to frame up both the challenge, but also the opportunity, this is really important for the energy transition and electrification. And conversely, it's a very big opportunity as a new market.
What happens today to a lithium battery? So lithium-ion batteries aren't new. We've had laptops and small electronics using them. So when I take my battery to the recycling center, does it get recycled today and does it go back into product? Or what's different between what you're talking about doing at scale than what's happening today?
Yeah, so historically, lithium batteries were really perceived as a waste. And I'd say in our world today, we were started 2016. And so when we started the company, that was kind of the pervasive sort of thought. Today, I'd say it's shifted quite a bit. Nonetheless, and maybe to frame it up, lithium batteries, we really think about it in four broad categories. And Chris, you're talking about one of those categories, which is, consumer electronics and appliances. That's certainly one of the streams that comes to us. Also think about it just to help frame the conversation, electrification, so EVs and the like. A third category, which is important, is manufacturing scrap. So as you make batteries, it's not perfect. And then also stationary storage, number 4. So could be residential, could be utility. So back to your question, Chris, today what happens is, frankly, for consumer appliances and batteries, not very good collection rates. North America, we're probably about 5 to 20%, depending on where you are, collection rates. So first off, it may not even go to recycling. I think we all have the proverbial drawer at home of devices and potentially batteries. And if it does go to recycling, what's been historically the case is often export for those batteries or treatment of them through thermal recycling, which is really where groups have been after nickel and cobalt, but you lose lithium that way. So that's not very economically advantageous, nor is it, frankly, environmentally very friendly. So what we're doing is non-thermal, and it's really bespoke for lithium batteries, not trying to be a generalist recycling facility for metals, if you will.
Ajay, you mentioned environmental friendliness. So when you compare the urban mine to conventional mining, what are the metrics that matter, and how do you compare on an expense or energy emissions intensity?
Yeah, maybe we'll tackle it two ways. One on CO2 footprint from a life cycle perspective, and then also on economics. So from a CO2 footprint perspective, and often what's happening with our customers, like the vehicle OEMs or even cell makers, very focused on the ultimate CO2 footprint of the battery in the vehicle, and hence the overall footprint of the EV. And the battery is a large part of the footprint for CO2 for a vehicle in EV. So the big metric and what we can enable through recycling is about a 2/3 reduction of the CO2 footprint of the battery within the EV. And that's a big deal because often a big knock against EVs is, well, you have to drive them a certain amount of distance before you start getting across a tip over point where you're actually creating a benefit in terms of the overall emissions reduction. And so that's a really big benefit. And that's why there's such a big focus on recycled material coming into new batteries, which can help reduce that footprint substantially. Economically, of course, this has to work economically. And from our founding, that was always one of the core tenets. We can't be reliant on, for example, government subsidies, because ultimately that's a cost passed on to the consumer. And so the good news is lithium-ion batteries, unlike other recyclable verticals, have a lot of valuable material. And that is the real driver of economics. So we have main revenue drivers from lithium, from nickel, from cobalt. Compared to mining, often you have, for example, lithium mine, they only have one revenue stream. For example, lithium. You don't find lithium with nickel and cobalt in the Earth's crust. So we're economically off the bat advantaged. And the way to really tap into that is the way that you process. You have to make sure it's scalable, low cost, and some of the environmentally friendly aspects tie in because you can process smarter and better environmentally, which helps from an economic perspective.
That's great. And what percentage of the battery materials, whether that's lithium or cobalt or manganese, what percentage are you able to recover in the recycling process?
And that links also back to your prior question about like what's different about what we do. So historically, one of the big metrics is recovery or recycling efficiency rate. The latter is basically a measure of how much mass goes in versus how much mass goes out and back to the economy. So historically, some of those thermal methods may have a recycling efficiency rate of about 50%, 60%. Through what we do, both Spoke and Hub, we can enable, up to an 80, even potentially 90+% recycling efficiency rate. That's just on a pure mass basis, like what comes in, what goes out, back to the economy. And then on a recovery basis, okay, so people say, hey, how much lithium comes in, how much goes back in the lithium product or nickel or cobalt? That's where we can enable up to 95%. Historically, nickel and cobalt would be maybe net 60, 70% recovery through historical methods. And lithium historically has not been recovered actually through recycling lithium batteries. And that's a key aspect of our economics. Lithium's a large part of the value. Even though lithium prices oscillate and they've come down recently, it's still an important contributor to the overall economic whole, plus the nickel, plus the cobalt.
Mm-hmm.
Oh.
Is there a...
How advanced are we at this point, right? So I get that you can get a lot of material back, but you need inputs. So where are you getting all these batteries to do this urban mining or getting the things back into the cycle, right? Because we need to still get it initially from the earth.
Yeah, and I think that's a great and classic sort of perspective, right? So I think most people, when they think recycling, you think end of life, you think spent batteries, you think EVs have gone on the road, need to come back. And certainly we've accepted a lot of EV batteries from the road. The thing that's missing in, I think, from a public perspective is when you make batteries, it's not perfect. And you generate a level of manufacturing scrap or rejects. Like most manufacturing processes, no manufacturing process is perfect. I always draw a bit of an analogy, the stamping industry for stamping of panels, for example, in the automotive space. Even today has, a level of offcuts and rejects, which could be, 5%, maybe even potentially more, depending on the plant. So very similarly, making a batteries, you get, for example, making a cathode or the anode. Cathode is a positive terminal, anode is a negative terminal. These are long sheets of material from which they cut out to size what's going to go in the battery. You get natural geometry-driven offcuts. So that's an example of manufacturing scrap. As they test the batteries all along the way, from a constituent of the battery cell all the way to a cell to a pack, there's rejects. High quality bar, right? No one wants a recall, right? No one wants something to have happen to those batteries when they go in the economy. So again, that's a level of manufacturing scrap. So all in all, that's about 10% on average we see of what goes into making a battery often comes at as some level of scrap. And you can imagine as you make a lot of batteries, that's quite a bit of scrap. And that's the reason that we've been building out and expanding in the near term. So there's a great market, I'd say, this decade driven by manufacturing scrap. And really the next decade market, so say 2030 and beyond, will be really driven by what I think people rationally think about, which is end of life batteries.
Does recycled material count as domestic content for the EV incentives?
It does. Yes, it does, in short. And so that's why there's been an even further focus on recycled material domestically, say within the US. And also, I think you're referring, Jeff, to the IRA and some of the requirements for the $7,500 tax credit. The interesting kind of juxtaposition of that is in the US today, you take lithium as an example, whether it be for mining or recycling. The US today is about a 5,000 ton per year lithium carbonate producer. Keep in mind today, the lithium carbonate market globally is about 1 million tons. So really, we're a massive, say North America even, a massive disproportionate consumer versus producer. So from a recycling perspective, as we think about our first refining facility producing about 8,500 tons of lithium carbonate, that's actually quite impactful. And so it's quite impactful from an overall market perspective. And secondarily, to your point, Jeff, it will count towards those domestic credits in terms of getting the $7,500 credit.
Quick follow up. Can you just put that in context? So in 2024, the percentage of new EV batteries by mass will be 5% recycled content. And then by 2030, it might be 20, help us out with today and then maybe a steady state.
Yeah. So today, the main recycled content you see in batteries is really nickel and cobalt. And so of the nickel and cobalt, it may be a couple of percent, maybe today. And lithium typically not today because there hasn't been much lithium recovery from lithium batteries. You go to 2030, I'd say, recycling can be about, maybe 10%, 15% of the overall demand for lithium, nickel, cobalt as an industry. And that may not sound like a lot, but you're dealing with in the backdrop, even despite near-term oscillations of demand, which you kind of need to ignore on a long-term basis. That's quite a bit, right? You have a market that's growing potentially 20% a year, 30% a year, 10, 15% of that from nothing, really, is quite a bit. And then I fast forward even further to 2040 and beyond, then there's potential for us to be as an industry, 30%, 40%, 50% of the demand from recycled material. And then you really start to be very impactful on a long-term basis.
So when you get that big, I guess, how much energy is used in the process? So you talked a little bit about the process in the opening comments here. How much energy intensity is involved in converting this?
Yes, it depends on, this is where then you get into the technology, and it depends on how you're recycling. So some methods of recycling are relatively energy intense. Some of those historical methods I referred to, like thermal recycling, now it could be like metallurgical coal that's being used to create the thermal energy, but nonetheless, quite a bit of energy needed to run a furnace, for example, or run a kiln. Still, frankly speaking, on a net basis, still a benefit probably from a CO2 perspective, depending on what you're recovering. But the way to make that even better, and this is what Lifecycle does, is in summary, we have regional facilities that are shredding facilities where we take in the batteries, we convert them from being a battery or could even be a waste into a product. And one of the main products out of that is something called black mass, which is the cathode anode material. So that process is mainly shredding. It's a submerged process, not a lot of energy to be used. I'm talking like not even a megawatt of power usage, say per site. So way less than that typically. So that's kind of the first step of what we do. We have 4 of those facilities operating today. And then at the hub, so we call it a spoke and hub model. Think of it like a wheel, reverse logistics. And then the hub is where we refine. That's a wet chemistry process, again, non-thermal. Not very energy intense. We're less than a 20 megawatt load. To give an example for that facility, we're in the old Kodak Business Park. There's a utility in the park. We're a relatively small load for them for that utility. So not that energy intense yet again. But you could imagine, depending on what you're doing, if you're running a big furnace, okay, well, maybe you are quite energy intense. So then the devil's in the detail on the style of processing, really. And in our case, it's not that energy intense.
Would you ever supply pre-processed materials to others, or is it vertically integrated from a supply chain perspective?
That's a great point. And we today do sell our black mass, so that cathode anode material. Why it's called black mass, rather just appears like a black powder. It's a very creative engineer. I swear an engineer came up with the name. But anyways, yes, today we do sell that black mass to third parties. We sell it through our offtake and marketing partners. There's not a huge, it's a growing market, but there's not a huge market yet for that to be consumed. The traditional way it's been consumed, as I was basically outlining there, has been going into that nickel industry, basically. So it's been used as an additive to get more nickel and cobalt as part of nickel processing, basically. The downside of that is you don't get the lithium. And that's what we've been looking to change. So short answer is yes, we can definitely sell to third parties, but the real vision here is to be vertically integrated to go back to the battery materials. And why is really twofold. One, there's a lot more value in that. So from an overall financial perspective, that's the key strategic change, if you will. And second, from a closed loop perspective, when you think about an auto OEM or a battery maker, increasingly what's happening is they're saying, okay, I have this scrap, or in the future I'll have these end-of-life batteries under warranty. I, as in them, would ideally like the material back, right? So I want to give it to you, and then I want a pro rata amount of those metals back, ideally, because then I can offset as the OEM, or they can offset the amount that they need to purchase from a mined source. So if you think about that, it's like, okay, well, if you're producing black mass, they don't consume black mass, but they do direct sourcing, for example, for lithium or for nickel cobalt products. So that's a large part of the strategy in terms of how do we really enable for our customers.
So does that change the dynamics of either vehicle ownership or storage ownership then longer term? Do I actually own those minerals or do I lease those minerals? What happens long term?
Yeah, so ever since I started this, myself, my co-founder, since I started this business in 2016, this is the question we've been asked a lot. And I think for the first time in the last couple of years, we're seeing business models that actually enable that. So to give you an example, leased battery packs in vehicles, right? This is quite a common model even in Asia, even Europe to an extent. We've seen some try to come with it to North America. So the purpose of that model, in part, is to retain access, if you will, to those battery minerals after they've, really it's the OEM taking on the risk, right? That's passed on to the consumer for the purchase of those minerals at that time, at that price. So ideally, by not selling it, you kind of locked in your risk exposure as the OEM, and then you could potentially bring it back and recycle. So that's one way we're practically seeing that manifested in the market. The second way we're practically seeing that manifested in the market is what I was covering there on this whole closed loop concept. So one of the future potentials for us, which has a read through for consumers, whether it be in stationary storage or even in EVs, is recycling as a service. And so what we're hearing from a lot of our customers, as I was saying there on the OEM side, is even one step further. Not only do I want a pro rata amount of the nickel, lithium, cobalt that I give you, but frankly, I may want to own those materials all the way through your chain. And so recycling as a service, RAS, is a life cycle take on SaaS for the recycling industry. And we've taken a cue from, say, the industrial gas business, where you kind of have potentially a fixed fee model, to have a reservation fee, and then a variable fee, which is driven by usage. Because sometimes in the recycling industry, it's kind of hard to predict how much comes out from manufacturing scrap or other places. So that's the future of where we'd like to go. And it lends right into that model of the ownership of the materials.
So kind of a quick follow up, do you envision then that there'd be a premium on the recycled product since it's perhaps better for the environment and less impactful?
Yeah, we don't. So on the one side, from a economic banking perspective, we don't really rely on that. But on the flip side, there are a lot of drivers why there could be and should be a premium. Um, you know, and I'll kind of divide it between North America and Europe briefly. In North America, you have, I'd say, the incentive structure through the IRA for more domestic content, for more recycled material through things like the production tax credit. So you could see, flow through of that $7,500 EV credit backwards potentially onto the materials, and that could be part of the justification for a premium. In Europe, um, it's even more prescriptive, I would say. So there are, in the battery regulation that's now live and active, there are minimum requirements for recycled content in batteries. There are big expectations on the recovery of materials through recycling. So in that market environment, you could see even more reason for a premium for recycled
Now,
material.
last follow up, because when you were saying that, what comes to mind is EV batteries only a certain amount gets used for EV, and then they get upcycled into perhaps storage or something else. Does this change the model of how long we tend to keep a battery in cycle? Like, when does a battery become a
Yeah.
candidate for recycling as opposed to just going into a warehouse to be used for long term storage or some other use?
And we've seen a big oscillation on that, right? Between this desire and for reuse being first before recycling. And I'd say, broadly speaking, for industry, if it can be reused, then great. Well, I mean, we'll support that. There's no reuse for versus recycling issue. But from a customer perspective, I think what's driving that, frankly, is the cost of new batteries. And so, as we've seen the price of commodities come down recently, it has a direct flow through to the price of new batteries. And if that battery is going to be reused, basically, whoever it may be as a counterparty, they're going to have to be juggling, okay, well, how much does that used battery garner versus a new battery? And is there an economic case there? And once upon a time, there was a big case, right? Say you're like $1,000 a kilowatt hour, probably 10 plus years ago. Okay, yeah, I mean, that's very valuable. You want to reuse that. But today, if you're in around this $100 kilowatt hour less from a cell perspective, that equation may not stack up as well. So that's one part of it. And then secondly, and lastly on that, is the desire to get the access to the critical materials. Um, it's been such a big focus for folks and the desire to get back into new batteries. We're also seeing that playing a lot into the customer psyche around, do you reuse and delay the access to those critical materials?
Mhm. There's an additional dimension of the battery chemistry too. So you've mentioned cobalt and manganese, and there's a lot of trends now, maybe away from NCM and towards LFP. It sounds like because you're able to recover the lithium, you might be more agnostic to changing chemistry. Is that right, or does that matter?
Took the words out of my mouth, Jeff. Yeah, exactly. So we're agnostic to chemistry, and I think there's been two approaches in the recycling market that I've seen. One is there are some facilities that I've been to in APAC, Asia Pacific, where they only take, for example, a particular type of NMC chemistry. It's like NMC 622 or NMC 811. That's all they want. And that is one approach, but then you're highly reliant on that manufacturing scrap stream, which could very much change, right, in a pretty short order. Our approach, vice versa, because we're investing in ideally long-lived assets, we benchmark with the metallurgical industry, where some of the most successful businesses are the ones that are the most versatile. So being able to take the biggest gamut of material, still optimize within that, but be flexible, right? Especially in a market that continues to change. So short answer is yes, we take LFP batteries, we recycle them today. We can get the lithium from them. It is valuable for us. For others, however, that have a different approach, it may not be. And I think that's going to be an industry-wide sort of challenge that we need to continue to address, regardless of the shifts in chemistry. It's a pretty challenging thing as a recycler.
So, what other top level challenges are you seeing for the industry and trends if you have to think out more towards 2030? Where is this industry headed?
Yeah, I'll split it into three. First is just I'll just launch off that chemistry point for a moment, go a little bit deeper on that. That is quite a challenge as a recycler, because we're dealing with new chemistries out of manufacturing scrap and old chemistries out of spent batteries. So any given moment, that feed to us can be quite variable. And so the way we've dealt with it is that our spokes are highly agnostic, they're a mechanical system. At the hub level, what it means is we need to have, and we do have, a broad gamut of customers so we can be kind of managing composition of black mass. But that is a challenge, right? And I think what's been very interesting to watch on this side is uh, as commodity prices move, sometimes it could be for performance reasons, but sometimes it also causes the battery chemistry strategy to oscillate for our customers. And so that means you can have very short lives and strategies for some of these chemistries. Just bottom line is you have to be agnostic and flexible. The second is briefly is form factor. So we've seen not only the chemistry, but at a pack level, Tesla, CATL, others, BYD have gone to these very integral designs where you basically have cells in a pack, cell to pack architecture. And when you start layering on adhesives and things that make it hard for the packs to be dismantled, there are fewer and fewer homes for those packs to go. We take them because we can shred full packs without any discharging or dismantling. But I would say we don't see many outlets for that. It's an advantage for us, but as an industry, as the pack construction continues to evolve, it has implications for who can take it and actually recycle it. And then the last point I just make is the really challenging part of the whole build out here. I mean, the spokes are a lot of smarts there, they're lower capital and quicker. It's really the refining side. We see a lot of refining in China, even Korea, but North America and Europe have lagged with respect to the build out of refining for these materials, especially from black mass. And so that is a challenge as an industry in North America and Europe. We have to keep up in something that's more capital intensive, longer lead, more sophisticated. You need technology. So we're tackling that challenge, but there needs to be a bunch of us doing it.
So you just gave a great explanation of the challenges and the kind of ever moving target of the industry you're going for. I guess as you keep talking about black mass and things like that, how does one's personal journey go? Hey, I want to deal with black mass and solve this recycling problem. How did you get here?
Yeah, and it did. I learned about black mass subsequently. So, it really started with the critical materials. I actually came with Tim, my co-founder, from the primary mining, refining, particularly refining industry. So I used to work in lithium and nickel and cobalt. Now, this is now almost 13 years ago, but at that time, we were working nickel and copper and the like, and yeah, so it happens all those things are now used in batteries a lot, but at that time there wasn't a lot of that industry for batteries. But the new and very battery specific material was lithium. And so we spent a lot of time. I was at a firm named Hatch, which is an engineering firm. We were building facilities basically for clients. Tim, my co-founder, we spent a lot of time building the lithium practice at Hatch. And so after a couple of years of doing that, and it's been like various editions, if you will, of lithium. I call that lithium 1.0. There was probably like lithium 2.0 in like 2015, 16. We just had lithium 3.0 and we're probably going to enter 4.0 in a bit. So the market's gone through these various oscillations. So probably between 1.0 and 2.0, we were increasingly wondering, okay, we're working with these clients. They're going to produce lithium. It's going to go in batteries. We look at aluminum, we look at copper. There's pretty mature recycling industries. But what's going to happen for lithium? And then we dug in, we found out what I was mentioning there on the thermal side. Oh, wow, geez, even when they go for recycling, the batteries today, like you can't even get the lithium. Well, that's kind of crazy. I mean, how is that supportive of a sustainable industry? So that was really the start of it. And then through the journey, this whole spoke and hub model that we iterated with our customers, we've had to learn a lot and develop a lot of acumen on the pre-processing side, even understanding logistics and the like. So went from there, but started with the critical materials.
Kind of an amazing journey. I guess as you're describing all the chemistry and all the industries, do you get a not in my backyard offense when you go to a city and want to come in? Are people afraid that you're going to be doing something toxic or scary when you're proposing a new location?
Yeah, I think lithium-ion batteries in general have a bit of a stigma, right, against them, and I think we've seen it right in public. Now, the key to that is then what do you do? How do you process? And so what we do, talking about the non-thermal step, it's good for us economically. It's good for us from a customer perspective. And it's also good from a permitting perspective. So we've permitted now 5 spoke facilities, and having that track record is helpful. But also not doing something that spews a bunch of pollutants into the air to have neighbors is very important, right? To not have that sort of reaction. So that's on the spoke side. And frankly, conversely, when we've seen facilities that have thermal treatment, there have been challenges with permitting for some of our peers. So that kind of tells you where it can go. And then secondly and lastly, on the hub side, that's a chemical process for us. I'd say very common with the spoke side. It's a lot of clear communication, engage early and often, and explain what we're doing. Because this industry is very technical. And I'm an engineer, so I often have to make sure I'm trying not to use too much jargon and the like. But trying to make it, one, relatable, but two, get people comfortable that we're not going to do something here that's going to be net negative, it's going to be net positive.
And moving forward for our audience and listeners, what's your advice to them about figuring out how the recycling and life cycle of their battery is going to take place? What should they be doing to pay attention?
Yeah, I think everyone can play a part here. I mean, it's difficult unless you're working at a vehicle OEM or a cell maker where you can have a big role if you're, say, involved in recycling. But as an individual consumer, how do we play a role? Well, we all have a range of devices and appliances that have lithium-ion batteries, and we potentially all have a collection of those. And so what I'd encourage is there are different programs. We work with a whole range of groups on this front. I'll give you one example, Call to Recycle. There's also others that are electronic waste recyclers that do this. Essentially, they're PAIL programs. You can go to your local Home Depot, or it could be Staples, Office Depot, whatever it may be, and they often have a box where you can drop off your device or even your batteries. That's a way to get it back in the supply chain. And then those groups will pass it on to a certified group, such as us. And that's a way to get your, say, above ground cobalt, lithium, even could be nickel, into the electrification supply chain as we build these domestic supply chains.
Ajay, thank you. This has really been a tremendous discussion. You've helped me understand how recycling fits into a circular economy in this critical sector of batteries for all sectors, including EVs. Thank you so much for being a part of this discussion today.
Thank you, Jeff. And thank you, Chris. And I'll just say the message to leave folks with is when you hear somebody say EVs are polluting, bad for the environment, going to end up in a toxic landfill, just know that that won't be the case, because there's a lot of valuable materials in there, and it's right business decisions, right environmental decisions to close a loop as part of a circular economy. So thank you both.
Ajay, that was a fantastic conversation for our audience. We hope you've enjoyed this content as much as we did making it. We look forward to seeing you again on the Insider's Guide to Energy podcast. We'll talk to you soon. Bye-bye.